All right, so this first unit is called 1D Kinematics. And so today we're just going to look at an introduction to motion. So a couple of terms that we're going to learn here: kinematics, vectors versus scalars, position, distance, displacement, velocity and speed, and acceleration. So starting with kinematics, kinematics is the study of motion of objects without reference to the forces that caused the initial motion. So the next, not the next unit, but the next one after that is all about forces, which causes motion. But for now, we're just looking at the actual motion of an object. So we use kinematics to predict position, velocity, and other quantities as time progresses. So a common example of a kinematic problem that you might see is, let's say we have a stuntman driving a snowmobile off a ramp that is angled at 30 degrees and he's traveling 20 mile per hour, that's mph. How far away from the ramp will he land? So those are some of the things that we will be able to predict by the end of this unit. All right, so we have scalars and we have vectors. Scalar quantities are quantities that do not indicate any kind of direction. It's just a magnitude. So, for example, time is a scalar. When you tell somebody the time, you don't say it's -3 o'clock or that happened -5 days ago. You just say 5 days, or you say 2 hours, something like that. Energy is another scalar. Distance is a scalar. So when you want to tell somebody some kind of distance, let's say a 100-meter dash, you don't say you have to run 100-meter north, for example. You just say it's 100-meter. And then speed is also a scalar. Vector quantities are quantities that indicate magnitude. So it's it's halfway a scalar, and it indicates direction. So for example, we have position is a scalar. If you want to tell somebody your location, you need to tell them uh, the direction to go based on their reference point. So for example, if you want to go from Cooper High School to Ryle High School, for example, let's just say they're 8 miles away from each other. You can't just say just drive 8 miles. You have to tell some kind of direction. Okay, velocity is also a vector. We'll talk about what velocity is here in just a second. Displacement, acceleration, force, momentum, those are all vectors that we'll learn about this year. And then we represent vectors with an arrow over the variable. So first quantity we want to talk about is position. Position is your location. Uh, it's the location of an object relative to a reference point. So the reference point is usually just the origin of your coordinate system. Usually we just use X or Y, and then if we want to, if we have a two-dimensional plane, we'll use R sometimes. And then the units for position are meter. So here we have a couple of examples. We have two one-dimensional coordinate systems, one that's only in the X direction, one that's in the Y direction, and then we have a two-dimensional coordinate system. And we want to describe object A, object B, and object C. We want to describe their position. So for the first one, the way we can do that is we could say position of A is -2 meters. Or we could also say 2 meter in the negative X direction, assuming that the units are meter for these. For the second one, we can say position of B is 4 meter. And since it's one dimension, you technically don't have to be specific about the X or the Y direction. So you could just say 4 meter, or you could say 4 meter in the positive Y direction. Okay, and then the last one is two-dimensional, so you do have to be specific. So one way to represent that position is you could say -1 meter in that variable right there is called X hat direction. Okay, we'll talk a little bit more about X hat and Y hat when we get to 2D kinematics. The main focus for us for now is just 1D kinematics, so we'll see a lot more of this in the future, but -1 meter in the X hat plus 3 meter in the Y hat direction, Y hat indicating the Y direction. And then another way you could represent a vector two-dimensionally is you can use the brackets that we have there, the greater than and less than symbols, and then the number in the first position is your x direction, number in the second position is your y direction. And if you have a three-dimensional vector, then you could add the z direction to the end of it also. All right, distance and displacement. So distance is a measurement of how far an object has traveled. We use the symbols d, x, and y to represent distance. Displacement is the difference between the final and the initial position of an object, also known as the straight line distance between 2 points. And so the picture to the right shows that. So let's say you have point A and point B, and let's say an object travels the dashed line path. If you were to measure every step that object took to get from point A to point B, that would be your distance. But if you wanted displacement, that is just the straight line distance from A to B. And another difference is distance does not indicate a direction, it's just a scalar quantity, whereas displacement, you would include a direction with that number. And again, for vectors, you have the arrows over top. The triangle, that's delta, and delta just means change. So that's the change in x, and that's change in y, or it could be both. All right, so speed is your distance traveled over time. And we're gonna calculate throughout the course 2 different types of speed. You have average speed, which is just your distance over time. The units for that are meter per second. To get your instantaneous speed, that's going to require doing some calculus, or if you're driving in your car, you have a speedometer that tells you your exact speed. So we'll learn a little bit more about how to calculate instantaneous speed rather. But for now, we'll just be calculating average speeds. And in a lot of cases, they're the same. Average speed is the same as instantaneous speed. If let's say you're on cruise control your entire trip at 60 kilometers per hour, as shown in the picture, your average speed would be the same as your instantaneous speed in that case. So velocity is change in displacement over time. Often, but not always, it has the same value as speed. So velocity includes direction. That's one of the main differences. But again, often it's going to be the same as speed. And a lot of times I will say speed when I mean velocity, and I'll say velocity when we could really use speed because they're the same so often. So to find average velocity, you just take your displacement divided by your time. Units are meter per second. And again, to calculate instantaneous velocity is going to require calculus, and we'll get there eventually. All right, last quantity is acceleration. So the rate of change of velocity. So if you want to think about it this way, let me go back here. Velocity is, or speed even, is the rate of change of displacement, or rate of change of your position over time. So velocity tells you how much your position is changing per second, whereas acceleration tells you how much your velocity is changing per second. So average acceleration is just the difference in velocity over time. Units are meter per second squared, m/s squared. Again, instantaneous acceleration is going to require some calculus. Okay, so at the very end of the PowerPoints, I'm going to put the standards that we are learning. And in the next video, we're going to actually go ahead and do some example problems in calculating some of these quantities.